Hello everyone. Today we will discuss the topic flexible manufacturing system. So in computer integrated manufacturing subject, already in previous lecture we have discussed the major types of manufacturing system. These were custom manufacturing system, intermittent manufacturing system, continuous manufacturing system, and flexible manufacturing system. So in previous lecture I have explained the types and majorly nowadays we are using the flexible manufacturing system in current industry scenario. So today more or we will focus on flexible manufacturing system. So this topic is divided into parts, part 1 and 2. Today I will discuss the part 1 of this topic. So I have already introduced about me. So now we will continue this lecture. So majorly we can introduce this flexible manufacturing system as a automated machine cell that consists group of some processing workstations interconnected with automated material handling and storage system. So particularly this is complete automatized cell that include some workstations, some kind of machines, group of machines that are working, that are connected with some automated material handling equipments and storage devices. So this particular setup we can define in another way also as a form of flexible automation in which several varieties of machine tools are linked together by a material handling system, and all aspects of systems are controlled by a central computer. So this particular flexible manufacturing system is most suited for mid variety and mid volume production range, means the industries or the organization where variety, not much variety but medium varieties and mid average volume production range is mid level, not so much high, not so much low. So in a in this particular this image or figure we can see the layout, how these different components are linked together. So initially like we have raw material storage roller conveyor system. So the raw material storage devices or roller conveyor feed the where the raw material is moved through different units. Then load unload stations where we load the raw material on automatic guided vehicles. So AGV means automated guided vehicle. So there are like two different AGV vehicles which is being used for moving the raw materials on particular area. So the raw material is moving across different machine cells, like we have CNC1, CNC2, CNC3, so three major workstations where the raw material are feeding, and these are being processed on machine by some different tools. So like we have three different machine tools, so the product is processed on machine in these machine cells, then through this way this end product is moved and we can get the final product unload station and we get. So again there is in between there is temporary storage area where we can store the temporarily our end product or the whatever we produce through this workstation. So all these systems are controlled by computer. We can get computer controlled workstations. So this is all flexible manufacturing system. So this is a example of flexible manufacturing system where are different components of flexible manufacturing systems like AGV, automated guided vehicles. Machining centers are connected in one sequence. In different washing station, control rooms are they are using being controlled these machines, tools, and stations. Then one area is fixed for coordinate machine measuring machine CMM. Then some one area is used for part review station. So this is area being used to review the product, or we can see, or we can check the quality checks. And this area is used for storage station. We can store the end products. And here we have some different kind of tools and fixtures. These are moving through some kind of some conveyor. Then we can load and unload these things. This is the loading and unloading stations. So these all are connected by your automated guided vehicles AGV. Also the our product moves through one station to another stations, and the variety of processes or that kind of operations take that go through different units. Or we can see this whole manufacturing system is arranged as per the requirement, or we can get the maximum efficiency of the system. So all the system are automated and connected. So we can see the actual industry scenario, or how, or the pictures we can see in one major industry, CNC industry of Cincinnati, Biltmore. This is US based CNC machine. So we can see in picture there are like 5 Cincinnati CNC machines. These are arranged in such a way that to see the flexible manufacturing system or example of FMS system. These are being used for some kind of operations or machining operation. So initially we can discuss the brief history uh, of your FMS part, or what is the basic history of flexible manufacturing system. So initially we can say in the market there were not much needed for that FMS system because there were no any foreign competition. So only the components were produced in one country, and not much competition were there because each parts and products were not export to another country. So as the competition grows, the quality was required. That quality required was high. So then we needed that such kind of system, that flexible manufacturing system that can, through which we can get major high quality products and products. So this FMS system was first commercialized for machining operations, and that required the prior development of NC, means after development of numerical controlled devices, this system was commercialized. So the concept, major concept, this concept is created through your David William I, British engineer during mid 1960s. In late 1960s, the first FMS machining system was installed at Ingersoll Rand Company in Virginia. So the first FMS system was patented in 1965 by Theo William, who made the numerical controlled equipment also. So the German industries, or German country, they implemented the first FMS in 1969 in cooperation with University of Stuttgart. Russia and Japan also implemented the FMS system in 1972. So this is the brief history of FMS system, how it all had, where it starts, and how or where it needed, and how it's start evolving. So now we before we go for FMS, we need to see why we needed this FMS system. So why we needed this flexible manufacturing system in our industry. So the external changes such as change in product design and product system. Then we need such system that can adapt to this kind of product design and production system. Now for optimizing the manufacturing cycle time, we need such flexible manufacturing system that can being used for optimization of manufacturing cycle time. To reduce the production cost also, we need flexible manufacturing system. To to overcome the internal changes like breakdowns or some kind of emergencies or some breakdowns in terms of toolings in machines. That kind of overcome, we need such kind of flexible manufacturing system. So first we need to understand what what kind of things or what kind of activities make the wall manufacturing system flexible. So first thing is, we can this flexibility or flexible manufacturing system, we could distribute in three levels. One is basic flexibility, or we can see what kind of basic flexibility we use in flexible manufacturing system. So in machine flexibility system, we can see the ease with which a machine can process various operations, means the capability of a machine that could process variety of operations. Second is material handling flexibility, a measure of the ease with which different part type can be transported and properly positioned at various machine tool in a system. So this is the flexibility of a material handling equipment that could accommodate varieties of parts, or then that could be used for transportation of these variety of parts to different machine tools in a system. Third flexibility is operation flexibility, that is measure of ease with which the alternative operation sequence can be used for processing a part type, means the varieties or alternative operation that could be managed by that some kind of processing equipment, or that could be managed. Second type of flexibility is system flexibility. So the machine or like the system, there are varieties of flexibility that is related to system, means one is volume flexibility. So the mid volume, low volume, high volume, that could be that could be accommodated by the system. Expansion means we want to extend some kind of, or we want to we can we want to explore or increase the volume or product, we can say quantity, some kind of expansion we want in system, that could be accommodated by that flexibility. Routing, like if we want to change route, or we have some certain modification in route of different process, then it could be accommodated by that system. Then process, if we need to change the process sequence or some kind of changes is required in process, that could be flexible. Then product flexibility, like if you have wide variety of products, that could be accommodated by the system, that is some kind of, that is one type of that flexibility. Then third is aggregate flexibilities. So one is program flexibility, means if we have some certain program, but if we have some modification changes in program, that could be accommodated by that system, that is called program flexibility. Then production flexibility, like if we have some changes in production sequence on production level, that could be accommodated. Then market flexibility means if we, as per the market situation or scenario, that process or system could accommodate or could be changed, that is market flexibility. So next thing is, we want to see the test of flexibility. In this slide, we want to see the different test of flexibility. So there are four reasonable tests of flexibility in an automated manufacturing system. Like one is a part variety test. Can the existing system or our manufacturing system could process different part styles in a known best mode? So that we need to see for our automated manufacturing system, whether the part varieties could be accommodated by our automated system or not. Second is schedule changeover test. So if we have some changes in production schedule or change in either part or production quantity. So that kind of changes could be taken by our automated system or not, that we need to see. Third test is error recovery test. If we have some certain equipment breakdowns or some kind of emergencies, that could be taken by our system or not, that we need to see in our automated manufacturing system. Fourth is new part test. Can we, if we have some new part design or that could be introduced in between in existing product, then it could be taken by our system or not. So these are different four tests, or the four parameters that could be accomplished by our automated manufacturing system or not. That then we can see this kind of flexibility we need to be in our system. In this slide we will see the classification of flexible manufacturing system. So flexible manufacturing system can be distinguished according to number of machine in system. So typically we divide in three major classification. One is single machine cell, second is flexible manufacturing cell, third is flexible manufacturing system. So in single machine cell SMC, in single machine cell, this particular machine cell can operate in batch mode. Batch mode means sequentially process the parts of single style in different load size. Means sequence by sequence the different parts are processed. So there are not variety, only single style of parts are processed in batch mode. Or flexible mode means the processed variety of parts and adapt to different production schedules. So this is the single machine cell. It also consists of one CNC machining center combined with a part storage system that is being used for the items or products which are not processed. So the complete parts are periodically unloaded from the part storage unit and raw work part are loaded into it. So in this particular figure and layout we can see how, where, means we can see here that this is complete your pallet. This is your pallet where we mount our work pieces or parts. So here we can see the shuttle cart with pallet and part. So particularly this is the track, how where this particular complete cart can move from one position to another position in this direction. Also this is the place where our part is kept for machining operation, and the operation is processed by our CNC machining centers. This is the CNC machining centers, and this is the tool storage where different variety of tools are kept or being used for different operations. So this is the whole, we can say, moving system, or like one uh, automated system that is being used for loading and unloading the different parts. So this complete shuttle track is used, and that shuttle cart with pallet is used, and this is the pallet with the part, or this is the, we can say, this is the also one part, this pallet holder that is being used for holding your pallet. So this is the whole your single machine cell, how this is arranged on different components of this particular cell. Second type is flexible manufacturing cell FMC, that consists of two or three processing workstation. Processing workstation means CNC machining centers plus with the part handling system and limited part storage for simultaneous production of different parts and error recovery. So in this FMC system you have three, as we can see in our this picture, three machining, two or three machining center, CNC machining center with your part handling system. This is your part handling system. We call it a work transport system. So this is particular track for your shuttle where our part is moving from one CNC station to another station, and this is connected to your load and load station where we can load or unload our raw material or end product. So the part handling system is connected to your loading and loading station. This is your flexible manufacturing cell. Third type is flexible manufacturing system, FMS. So here we can see in the system four or more processing workstation are connected mechanically by a common part handling system and electronically by a distributed computer system. So the other stations may support the activities such as coordinate measuring machine, washing station for simultaneous production of different parts and error recovery. So here in this FMS system there are four or more processing workstations. These are connected mechanically by a common part handling system, and again the computer distributed computer system are used to connect each parts, or all activities are carried out at subsequent or at one during operation time. So in this figure we can see the our variety of workstation. These are connected to your distributed computer system, variety of distributed computer system, and you have different system, other system like CMM, coordinate measure machine, and washing station for other operations. Now we can discuss the major components of your FMS, flexible manufacturing system. So major components are workstations, automated material handling and storage system, computer control system, and fourth is human resources. First is workstation. Following, or there are different types of workstation. These are being used in FMS, flexible manufacturing system. One is load unload station, second is machining stations, third is other processing station, some kind of assembly stations, inspection stations, other equipments and station being used for inspection and vision operations. So these are variety of workstation used in FMS system. So we already know the load unload station, machining station, processing stations, assembly, inspection. So these each stations have their own use and own role for different operations. Second system is material handling system. So the material handling system is completely automated, which is being used for transportation of work part and sub-assembly parts between the different processing stations. So the major function of these material handling system are random and independent movement of workpiece between different stations to handle the variety of parts, to handle these temporary storage parts. Then convenient access for loading and loading are done by these material handling system. Then majorly these are compatible with computer control, and these are the major functions. So whole thing is that the system or the equipments are used for handling the material from one place to another place in convenient way. That could accommodate or handle a variety of parts. So basically there are lot of equipments that are being used in material handling system like automated forklift and rail traveler. These are already given in picture. So there are all also varieties of material handling system. So already we have covered this topic in previous lectures, previous unit, because there is separate topic, material handling system or automated material handling system, where we have discussed in detail this particular different equipments used for material handling and their roles and how they work, how they are connected. Thank you very much for your attention. So we will continue our this topic in next part 2. We will discuss the next component of this particular FMS types third and fourth, and we will complete this topic.